Oh boy, we are starting a new chapter, and you're like, hang on, Mr. Blanchard. Yesterday we were on page 209, and now we're on page 476. What the heck? Well, if you were to, just kind of skim through your book, that stuff in between was all the trig stuff that we did in the black book. Okay? So we could have used this book for the entire um, course instead of switching to the black book. But I was like, we got to keep tradition alive and try to see how many years those black books are actually going to make it, like physically, how long are they going to make it? So don't worry. It's not like we're jumping 200 pages, 250 pages, 270 pages, 267 pages. Um, Forward, just for the heck of it, we've already covered all the stuff in between there, okay? So we are talking about 13.1. It's called arithmetic. That's right, arithmetic and geometric sequences. And you're like, what? And I'm like, don't freak out. It's all about patterns. Okay, so, oh, why can't you see all of this? There we go. Okay, an arithmetic sequence, the difference of any two consecutive terms is a constant. And you're like, what? All it means is like this. Here's a pattern, 2, 5, 8, 11. And your brain naturally tells you, duh, add 3, add 3, add 3. That's an arithmetic sequence. Okay? If you look at this one, 8, 6, 4, 2, 0, blah, blah, blah. Okay? Your brain automatically tells you, okay, I'm subtracting 2, subtracting 2, subtracting 2, subtracting 2. That's an arithmetic sequence. Okay? This one's a little harder to get. X, x plus y, x plus 2y, x plus 3y. But if you look at it just for a second, I'm adding y, then I'm adding another y, then I'm adding another y. And that is arithmetic sequences. Okay? So these patterns are pretty easy to see with your eye. All right? Because you're used to seeing those patterns. I'm adding 3, I'm adding 3. I'm subtracting 2, I'm subtracting 2. Okay? It's the same number each time in between the numbers. Okay. As opposed to geometric sequences. Geometric sequences, the ratio of any two consecutive terms is a constant. And you're like, ratio? What? This one over here said difference. This one says ratio. Okay. And don't worry, I'm going to go big screen here in just a second after I compare these two. All right, so that you can see. I'll go back to this slide also if you're really squinting at it right now. So if you look at this one, it goes 1, 4, 16, 64. All I did on that was multiply by 4, multiply by 4, multiply by 4. Oh, okay. That's a geometric sequence. If you look at this one, the one right below it, hello. 81, negative 9, 1, negative 1 ninth, 1 81st. I'm dividing by 9, sorry, dividing by negative 9, dividing by negative 9, dividing by negative 9, dividing by negative 9. Okay, I got that. And so that's a geometric sequence. And then this one down here, it goes x, xy, xy squared, xy cubed. I'm multiplying by y. Okay, so in other words, arithmetic sequences are adding or subtracting the same number. Hello. The same number. And over here, geometric, you're either multiplying or dividing the same number. Oh, don't you wish the book would just say stuff like that? The stuff in the black handwriting is um, how the book approaches it. Okay, so here we go one more time. Big screen, and you guys can pause this whenever you want. There's arithmetic, big screen. Okay, and then here's geometric, big screen. And you guys can pause those whenever you want. Moving on. Okay, T sub 1 is the first term in a sequence. Whenever we're talking about arithmetic, we're going to use the letter D. And whenever we're talking about geometric, we're going to use the letter R. So the first term is T sub 1. Anytime that we're talking about arithmetic, which is a slide over, we're going to use the letter D for difference. And then R is a ratio for geometric. Click. Okay. So sometimes the equation's going to be given to you. Okay. It's going to say, hey, what if there is some sequence that follows this equation, 2n squared plus 3. And you're like, I don't know if it's arithmetic or geometric. How am I supposed to do it? It doesn't matter. It just says, what's the first term? All you do is plug in 1. So you just plug in 1 where n is. You just plug in 1 where n is. So the first term is 5. If I wanted to know what the second term was, I could put 2 in for n. And turns out that answer is 11. Okay. Okay, and I could have just kept on going there. Next. An arithmetic sequence. So this is the big formula right here. Follows this equation. P sub n, in other words, to get the nth term, you take the first term and add on the difference, d, n minus 1 times. That's the equation we're going to use for this homework when it says arithmetic. Whoa. For geometric, we're going to use this equation. To get the nth term, you take the first term and you multiply it by the ratio n minus 1 times. Okay, so those are the two equations. Let me go big screen again, just in case you're squinting at these problems. Here we go. Okay, so arithmetic, here it is. And remember, you guys can pause this whenever you want. And here's geometric, big screen. Remember, you can pause that whenever you want. Moving on. Graphing is simple. Let's say it was an arithmetic pattern, 3, 5, 7. So obviously you're going up by 2 each time. The first term is 3, and the difference is 2, because the difference between these two dudes is 2. Okay? So I could come up with the equation based on the previous slides. T sub 1 plus, it's always n minus 1, times d, which is 2. Okay, so this guy right here is the formula 2 slides ago. Okay, so I took the first term. Come on. I took the first term, 3, and then n minus 1, it's always n minus 1, times d, 2. So now I'm going to distribute this 2. Whoa, I can't do that. So now I'm going to distribute this 2 here and here. Okay, the 3 just gets left alone. And then I'm going to combine the 3 and the minus 2, and that's how I'm going to get that 1 right there. Okay, so this right here is the final equation for that arithmetic sequence, 2n plus 1. So if I had to graph that, 2n plus 1, if n is 0, the answer is 1. If n is 1, the answer is 3. And then I would just graph it. And again, you can pause that whenever you want. Okay, let's do geometric, but this time let's not graph it. Let's just solve it. How about a geometric sequence where it goes 3, 4.5, and 6.75, and you're like, whoa, 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 those are decimals. That's scary. Not really. The first term is 3, obviously. And then you're like, how do I find the ratio? All you do is just take the second term divided by the first term. So 4.5 divided by 3 is 1.5. And so that means, hello, that the equation that we would use for this would be first term r n minus 1. Okay, I know there's more writing down here, but I'm not going to show you that part this year. There, you can't even see it. I'm not even going to scroll at all. Okay, so that's a geometric sequence. Y'all? Good. Let's do one. Yeah, we got to do this one. I think this is it, right? Yeah. Okay, last slide. Here we go, everybody. I'm just going to erase this. I'm just going to erase that and pretend like you are all don't have a clue what's going on. That way it's a little less confusing. Plus you can hear me as I'm working out the problem. There. There's more underneath there, but you don't know that. Okay. How about a geometric sequence where the third term is 12 and the sixth term is 96, and you're like, what in the what? So 1, 2, the third term is 12, 4, 5, the sixth term is 96, and you're like, what? How in the world am I supposed to do that? Well, algebraically, we're supposed to do this. Are you ready? Okay. I can still write an equation. It's just going to look weird. Let's talk about the third term. If I were going to use the third term, it would be the first term. Remember, this is geometric. Times, but I don't know what the first term is, times r, but I don't know what r is, to the n minus 1. Well, n is 3. And I know that answer. That answer is 12. Okay, so really, if I was talking about the third term, I would say it's the first term times r squared equals 12. All I did was just do 3 minus 1. Duh. Okay. Now, let's go over here and talk about the sixth term. Not in blue. The sixth term. Okay. Well, the sixth term is the first term times r to the n minus 1. Well, this time n is 6. But I know that answer. That answer is 96. So this would really be first term times r to the fifth equals 96. Okay. I can't solve this red equation by itself. I can't solve this black equation by itself, but I sure as heck can definitely dang it, you're not supposed to see that. Don't see that there. Ha! I don't even care if you pause the video. Big whoopity-doo. Okay. So I have two equations that have exactly the same variables. The first term, t sub 1, and r. So I can take this puppy right here and solve it for the first term. The first term is 12 over r squared. But I also know over here that the first term is 96 over r to the fifth. Hey, so if those are both the first term, I can set them equal to each other. 12 over r squared equals 96 over r to the fifth. Now I'm going to do a little handy dandy switcheroo. This guy's going to go up there, and that guy's going to go down there. So that would be r to the fifth over r squared equals 96 over 12. Well, I can actually divide that. That's r to the third. And I can actually divide that. That's 8. So I can do the cube root of 8 and figure out what the ratio is. It's 2. Okay. So now that I know that the ratio is 2, I can take that guy and plug it in. Let's do to the first one. The first term is 12 over r squared. The first term is 12 over 4, because r squared, it's 2 squared. So that means the first term is 3. Oh, okay, okay. So now, if the first term is 3, then I know for sure that t sub n, if I was, given an equation for t sub n, it would be the first term, 3, times r, 2, to the n minus 1. Oh, I don't know why I put dots. My bad. Okay, let's try it out. Do you remember what the third term was supposed to be? The third term was supposed to be 12, right? Yeah, the third term was supposed to be 12. Let's test it out. Does the third term equal 12? Well, it'd be 3 times 2 to the 3 minus 1. So that'd be 3 times 2 squared. Well, that would be 3 times 4. Ding, 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 winner, chicken dinner. So this question, I think, actually said, find the 11th term. Find t sub 11. So if I said find the 11th term, well, the 11th term would be 3 times 2 to the 11 minus 1. So it'd be 3 times 2 to the 10th. Oh boy, calculator time. Do 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 2 to the 10th times 3. 3072. Voila and voici. Okay. Sure hope that's right. Surely it is. Yeah, the 11th term, 2 to the 10th. 2 to the 10th is a big number. Yeah, it's 1,024. And then you're going to multiply it by the first term, 3. Boom. Okay? So, that's what I wanted to go through with y'all. And here is the big screens for those. You ready? Here's the big screens for those. So this was the original problem. There we go. Scrolling, scrolling, scrolling. Scrolling, 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 scrolling. Scrolling, 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 scrolling. And the assignment. Okay. So the assignment is page 476, 1 through 16 all. Try them. Don't cry them. Just try them. So today's the notes, you guys try to do the problems, and then tomorrow we'll talk about the problems. No problem at all. Ha ha ha. And that's it. This video was kind of lengthy. Oh well, that's just how it is. All right. I say to you, good day.